What will the future look like with intelligent machines? AI has been growing exponentially in the past decade. Artificial intelligence will probably be one of the biggest scientific breakthroughs in the 21st century.
The idea of using artificial intelligence to discover alien life is not just a sci-fi fantasy anymore. It's a real possibility that's got astronomers and tech enthusiasts buzzing with excitement. Imagine this: AI, with its powerhouse abilities to crunch data, spot patterns, and learn on the fly, becoming our cosmic detective in the vastness of space.
AI is really being used all across the space exploration enterprise, everything from making the spacecraft smarter to analyzing the huge data sets on the ground and then to operating things like the communications antennas that we need to talk to the spacecraft.
First off, think about the sheer amount of data we get from space missions and telescopes like TESS, Kepler, and the James Webb Space Telescope. We're talking about a mountain of information that would take humans ages to sift through. But AI, it can zip through this data, picking out relevant signals and dumping the cosmic noise, which is super important if we're trying to catch a whisper from an alien world. Now let's talk about patterns. Space is full of them, but we're interested in the weird ones, the anomalies. AI has a knack for spotting things that don't quite fit, like strange dips in starlight that might hint at megastructures built by advanced civilizations, or unusual radio waves that aren't just random space chatter. We can train AI models to be on the lookout for these kinds of cosmic oddities, but AI isn't just about looking at what's already there. It's also about predicting where we might find signs of life.
I just see it as a beginning. Not just this flight, but in this program, which has really been a very short piece of human history.
Using what we know about life-friendly conditions, AI can simulate different scenarios, guiding our telescopes to the most promising corners of the galaxy. Now this brings us to our next point. In 2015, while a massive Earth observatory was capturing evidence of the 4D fabric of space-time, scientists embarked on an intriguing quest. They pondered whether intelligent extraterrestrial beings might have constructed an enormous scientific structure, and if so, could we possibly detect it? This speculative idea might sound like science fiction, but it's grounded in a real scientific study. The study revolves around a star known as Boyajian's star, named after the lead author of the research. Situated about 1,470 light-years away, this star became the center of attention due to some unusual observations made by NASA's Kepler telescope. Researchers examining the data noted strange dips in the star's light, which sparked curiosity and a range of theories, including the possibility of an alien megastructure. This star's peculiar behavior led to widespread interest and speculation. The idea that we might have stumbled upon an alien creation was thrilling. But beyond the excitement, this situation provided a unique opportunity for scientists to explore and understand the myriad of natural phenomena occurring in our vast universe. Whether it's an alien megastructure or a natural cosmic event, Boyajian's star certainly gave astronomers and space enthusiasts something extraordinary to ponder. When we use telescopes to study stars, they often detect dips in the light emitted by these stars. It's like when you're looking at a bright light bulb and suddenly someone walks in front of it, causing a brief interruption in the light you see. Generally, these dips in starlight are caused by exoplanets passing in front of their stars, but things got really interesting with Boyajian's star. Unlike the usual spherical shapes we expect to cause these dips, the pattern observed at Boyajian's star was different. Daniel Giles, a researcher at the SETI Institute, made an intriguing observation during the 243rd meeting of the American Astronomical Society. He said that the objects causing the dips in Boyajian's star's light were not spherical, but rather appeared as a collection of panels. This unique shape led to some exciting speculations. Could it be an alien megastructure, something straight out of a sci-fi novel? This hypothesis set the astronomy world abuzz. Following the 2015 discovery, there was a flurry of activity news articles, follow-up studies, and a lot of discussions within the astronomical community. But let's cut to the chase. The eventual consensus was that these unusual light patterns were not the work of an advanced alien civilization. Instead, Giles later suggested that it was probably something much more mundane, like cosmic dust. Yet the very notion that it could have been something else, even briefly, captured our imagination. The story of how researchers stumbled upon the peculiar signals from Boyagin's star is almost as fascinating as the discovery itself. Daniel Giles revealed that these signals were initially overlooked in the Kepler data. It was actually citizen scientists engaged in a different quest who accidentally noticed the strange dips in light. Giles sums it up perfectly. People weren't looking. But now, that's exactly what he and his team are focused on doing. They're convinced that the key to uncovering the truth about aliens might just be hidden in plain sight, within the data we've already collected. Giles and his team are now embarking on a mission to sift through the vast data collected by NASA's Transiting Exoplanet Survey satellite. They're hunting for anomalies in starlight, dips that don't fit the usual patterns in shape, depth, or timing. These outliers in the cosmic data are their targets. The process is a blend of technology and human ingenuity. Test data provides around 60 million light curves, which are graphs showing the brightness of stars over time. Giles explains this as counting photons. To manage this colossal amount of data, they're turning to machine learning. The satellite has observed various sky sectors for about 30 days each, taking snapshots every 30 minutes. These observations have resulted in millions of light curves for stars brighter than magnitude 14. In the magnitude system, brighter objects have smaller numbers, so they have a lot of bright stars to analyze. The team's strategy involves organizing these light curves based on characteristics like shape and periodicity. Giles mentions the need for cheap metrics for initial sorting, followed by more detailed analyses for promising candidates. This two-tier approach helps in narrowing down the immense data to a manageable size, ensuring that any significant findings are not just instrumentation errors, but actual astrophysical phenomena. But here's where the human element comes in: manual inspection. Giles believes that nothing is better at finding weird stuff than the human eye. This sentiment is echoed in their approach. Despite the advances in machine learning, it's the human capacity to spot anomalies and make intuitive connections that drives this search. Giles emphasized the limits of machine learning in this context. Without a ground truth or a known standard for what constitutes weird or interesting, machines can only go so far. It's the human knack for detecting oddities and piecing together information that might eventually lead us to discover something truly extraordinary, like evidence of intelligent alien life. This blend of technology and human curiosity underscores our quest to understand the universe, a quest driven as much by our sophisticated tools as by our innate sense of wonder. The challenges scientists face in understanding and replicating human movement in robotics offer a fascinating parallel to the hurdles encountered in machine learning and artificial intelligence, particularly in the field of astronomy. It's like this. We as humans often don't fully understand the intricate details of how our bodies work. They just do. Take our fingerprints, for instance. Only recently, research has made a breakthrough in understanding how fingerprints enhance our grip. It's something we do instinctively, like holding a slippery dish just right to prevent it from falling. Scientists had to actually create a new law of physics to explain this seemingly simple human instinct. This dilemma mirrors the challenges in ML and AI. How do you program a machine to search for something we haven't discovered or don't fully understand yet? It's akin to the excitement surrounding the James Webb Space Telescope, heralded for potentially answering cosmic questions we haven't even thought to ask yet. Daniel Giles acknowledges these limitations in artificial intelligence and machine learning, but he also sees immense potential as long as we understand the specific roles these technologies play. It's a balancing act between leveraging what AI can do and recognizing its limits. But here's an interesting twist. Giles and his team are actively trying to bridge this gap by programming specific anomalies into their search algorithms. They've injected nearly 2 million artificial signals into light curves. These are the graphs that show how the brightness of stars changes over time. The goal? To see if their systems can detect these anomalies, which could indicate something unusual happening in space, like the elusive megastructures they're curious about. So far, the results haven't pointed to any alien megastructures, but they've certainly uncovered some intriguing data. It's a journey of discovery, where each new finding, even if it's not the anticipated megastructure, adds a piece to the vast puzzle of our universe. The effort underscores a crucial point in scientific exploration. Sometimes the path to uncovering big answers lies in the search for the right questions.
Did you knowingly lie when you said you had actually seen anti-gravity propulsion in operation? No.
I mean, it's to be on that cutting edge of technology is so alluring to me.
Bob Lazar's tale reads like a page ripped from a science fiction novel, yet it's a narrative he's presented as his own real-life experience, captivating those intrigued by the mysteries of ufology for years. Imagine a young scientist, previously working on a classified particle accelerator project at Los Alamos National Laboratory, catching the eye of military contractors. This isn't the plot of a movie. It's how Lazar describes the beginning of his journey into the depths of one of the most secretive projects related to extraterrestrial technology.
I did get a chance to look inside the craft on only one occasion, and this was important because where the reactor sat might have been critical to how it operated.
Lazar claims he was whisked away to work at a site known as S4, a place so shrouded in mystery it could easily be mistaken for a mirage in the Nevada desert, just a stone's throw from the infamous Area 51.
You used to work at Area 51.
Well, you know, we want to be accurate.
Okay.
Area S4.
S4, okay.
It's about 15 miles south of Area 51.
According to him, S4 was ingeniously camouflaged against the desert backdrop, designed to be invisible to the untrained eye and to keep prying eyes at bay. The security at S4, as Lazar recounts, was nothing short of what you'd expect for a facility rumored to house the secrets of the universe. Armed guards, surveillance cameras at every turn, and an advanced security system that could read the very bones in your hand. It was clear that whatever was being hidden here was of paramount importance. Lazar paints a picture of a work environment governed by the principle of need to know, where information was doled out sparingly, ensuring that the secrets of S4 remained just that, secrets.
Did you ask any questions about that?
No, there's no asking questions.
There's no asking questions.
No.
At the heart of Lazar's extraordinary claims are his alleged encounters with 9 different extraterrestrial spacecraft, each with its own unique design and capabilities. Among these, the Sport model stands out, a disc-shaped craft that seems to leap from the pages of a 1950s sci-fi magazine.
There were 3 seats. They sat around, the reactor was in the dead center of it, and then equidistant around there were 3 seats. And that's all.
He describes being part of a team tasked with reverse engineering the propulsion systems of these crafts, systems that defied all known laws of physics.
Look, everyone doesn't necessarily start at a steam engine and go to an internal combustion engine and then, you know, electric power, nuclear power, and go up the ladder that we come on.
Central to these propulsion systems, Lazar claims, was element 115, a substance not even recognized by science at the time of his disclosures, but later added to the periodic table as moscovium. This element, according to Lazar, was the key to unlocking anti-gravity propulsion, allowing these crafts to perform maneuvers that would be impossible for any human-made machine. Lazar provides vivid descriptions of the craft's interiors, specifically the Sport model, which was equipped with a central reactor and 3 gravity amplifiers. These components, he says, could manipulate gravitational waves, allowing the craft to bend space-time and travel at unimaginable speeds. It's a concept that, if true, would revolutionize our understanding of travel and propulsion. In 1989, Lazar decided to bring his story to the public, sharing his experiences in interviews that would ignite a firestorm of debate and speculation. His claims were met with skepticism, as many questioned the veracity of his education, employment background, and the feasibility of the technologies he described. In 1989, Bob Lazar did something that would forever change the landscape of ufology and how the world views the secretive military base known as Area 51.
How would you describe it?
I guess within the Area 51 compound, you can call that a subset of Area 51.
With a mixture of concern and a sense of duty, Lazar stepped into the spotlight on Las Vegas television, guided by investigative reporter George Knapp. He wasn't seeking fame. Instead, he was driven by a belief that the public had the right to know about the advanced technology he claimed was being concealed by the government. His revelations opened a Pandora's box, challenging us to question the boundaries of our knowledge and what mysteries the government might be keeping from us. However, Lazar's extraordinary tales were met with a healthy dose of skepticism. Critics were quick to point out the inconsistencies in his narrative, the apparent absence of evidence to back his claims, and the puzzling gaps in his academic and professional history. These controversies have swirled around Lazar, casting shadows of doubt on his credibility.
Again, I forgot where the hell I am.
Yet, despite the skepticism, Lazar's story has ignited a global conversation, thrusting Area 51 from the shadows of obscurity into the glaring light of public curiosity. Lazar's impact on the cultural zeitgeist cannot be understated. His allegations have fueled the imagination of millions, leading to an explosion of documentaries, books, and heated debates. Area 51, once just another top-secret military site, is now synonymous with alien technology and cover-ups, thanks in no small part to Lazar. His claims have kept the conversation about UFOs and the potential for alien contact alive, engaging a new generation of seekers and skeptics alike. The debate over Lazar's credibility continues to rage, with opinions sharply divided. Yet, regardless of where one stands on the issue, it's clear that his narrative has significantly shaped the discourse on extraterrestrial technology and government transparency. Bob Lazar's tales of his time working on alien spacecraft give us a peek into what sounds like the set of a sci-fi movie, especially when he talks about the sport model UFO. Picture this: a sleek, disc-shaped craft that seems to have leaped right out of the pages of a UFO conspiracy theory into reality. Lazar says this design isn't just for show, it's about aerodynamic efficiency. Imagine a vehicle that glides through space, air, and maybe even water with the greatest of ease. Its disc shape cutting down on resistance and allowing it to zip in any direction it pleases. It's the ultimate in alien engineering, blending the iconic look we've all come to associate with flying saucers with practical design features that make interstellar travel a breeze. But let's get down to specifics. According to Lazar, the sport model isn't some behemoth mothership.
What is roughly the size of this thing?
We came up with 52 feet in diameter.
This compact size hints at a craft designed for nimbleness, perhaps used for quick trips across the cosmos rather than carrying loads of extraterrestrial passengers. And it's not just any old material making up the exterior of this UFO.
There are no, first of all, everything is one color. It's like a dark pewter color, and there are no right angles anywhere.
Lazar describes it as a smooth metallic surface, suggesting it's built to survive the harsh conditions of space travel. From withstanding the bombardment of cosmic radiation to shrugging off the impact of micrometeorites, this material, whatever it is, sounds like it's pretty tough stuff. Lazar even hints that it might be some kind of unknown alloy or advanced metamaterial, specially chosen for its propulsion and stealth capabilities. Diving into Bob Lazar's account of the sport model UFO, he paints a picture of an alien craft that's as intriguing on the inside as it is on the outside. According to Lazar, this isn't just a flying disc, it's a marvel of extraterrestrial architecture cleverly divided into 3 levels, each with a distinct purpose. It's like the designers, whoever or whatever they might be, took a page out of human engineering books but then added a twist that's out of this world. Starting at the bottom, the lower level of the craft is where all the magic happens, so to speak. Here lies the heart of the UFO's propulsion system, equipped with 3 gravity amplifiers and their waveguides. These aren't your average engine parts. They're the components that supposedly allow the craft to bend gravity to its will, making it possible to zip across the cosmos with ease. The strategic placement of these amplifiers at the craft's base is a thoughtful touch, ensuring stability and a smooth distribution of gravitational energy. Moving up to the middle deck, we find the crew's quarters. Given the UFO's overall dimensions, space here is at a premium, designed for occupants a bit smaller than your average human. This level likely packs in the essentials for life support and day-to-day operations, although Lazar leaves us guessing on the specifics of how these systems cater to the needs of its non-human users. It's a compact, efficient layout that makes you wonder about the daily lives of its extraterrestrial crew. At the top, the craft features a control hub that sounds like something straight out of a science fiction saga. The navigation and control systems here are said to be unlike anything we're familiar with, possibly incorporating holographic displays or even direct neural connections for piloting the craft. It suggests a level of technology and user interface design that humanity can only dream of, tailored for beings with physical traits quite different from our own. Lazar also notes an astonishing detail about the UFO's construction. There are no visible seams, rivets, or any signs of how it was put together. It's as if the entire craft was manufactured in one piece, hinting at a process that could involve molecular-level precision or materials that self-assemble. The overall design, with its disc shape and thoughtful distribution of internal systems, speaks to a philosophy where adaptability and efficiency are paramount, ensuring the craft can handle whatever the universe throws its way. Central to his eye-opening claims is the propulsion system of these alien crafts, powered by something straight out of a sci-fi novel, Element 115, or Moscovium, as it's known today. Back when Lazar first shared his experiences, Moscovium was a mere hypothesis, absent from the periodic table and unfathomable to mainstream science. Yet, according to him, this element was the key to unlocking gravity-defying travel across the cosmos. Lazar's description of using Element 115 sounds like alchemy of the future. He talks about a stable isotope of this element, undiscovered and unproduced on Earth, that could harness immense energy through an antimatter reaction. We're talking about converting tiny amounts of material into vast amounts of power, enough to fuel the craft's journey through the stars. This process, according to Lazar, could generate gravitational fields, propelling the spacecraft in ways that defy our current understanding of physics. But how exactly does this craft move? Enter the gravity amplifiers. Lazar describes these as the linchpins of the spacecraft's navigation, capable of bending gravity to the craft's will. With 3 of these amplifiers on board, the craft could maneuver with unparalleled agility, hovering, taking off vertically, and gliding in any direction as if the laws of motion were mere suggestions. This isn't just about speeding through space, it's about reshaping the fabric of reality to move from point A to point B. The implications of such technology are staggering, offering a glimpse into a mode of travel that could take us to the stars and beyond without breaking a sweat. Lazar's accounts, whether you choose to believe them or not, ignite the imagination and challenge us to consider the possibilities that might lie just beyond the edge of our current scientific understanding.